Let's say that some particle is moving up or down, so it's moving in one dimension, the vertical dimension, and we know its position is a function of time. Its position is given as a function of time as t to the third power minus 6t squared plus 9t. And we're going to assume that our time is greater than or equal to 0. So you could imagine a dot here moving along this vertical line. Maybe it moves up, it slows down, maybe it stops, maybe it switches direction, maybe it comes back down, maybe it slows down, it comes back, and maybe it moves up, back up again. Who knows what it does? We really haven't analyzed this thing right over here yet. But what we do want to analyze over the course of this video is, when is the particle speeding up? So when is it speeding up? When is it speeding up? And before we think about that, let's just think about what it means to speed up. Well, let's think about the situation where the particle is moving upwards. And let's just say upwards, the upwards direction is positive. So when it's moving upwards, its velocity as a function of time is greater, or at that moment, our velocity is going to be greater than 0. And so if we're moving up, what does it mean to be speeding up? Well, that means our velocity should be increasing in the upward direction, or that the acceleration should be positive as well. So to be speeding up, our acceleration at that time should also be greater than 0. If our acceleration was 0, then we would be moving at a constant velocity. If our acceleration were negative right over here, that means we would be slowing down. We would be decelerating in that direction. Now let's think about when else we could be speeding up. Well, if our velocity at some moment in time is negative, and our acceleration is also negative, then we will be speeding up in the downward direction. Our velocity is already negative. We're already going downwards, but then we're going to be going downwards faster and faster and faster. Our velocity will become more and more and more negative because the acceleration is less than 0. So these are both the cases when we would be speeding up. And so now that we've clarified that, I encourage you to pause this video and try to answer this question. Over what intervals of time, if any, will this particle be speeding up? Well, to answer that, let's just try to figure out the velocity as a function of time and acceleration as a function of time. And we know that velocity is just a derivative of the position function with respect to time. So let's write that down. So I'll do it right over here. Our velocity as a function of time, the derivative of t to the third power is 3t squared minus 12t plus 9. And our acceleration function is going to be the derivative of the velocity function with respect to time. So our acceleration function is going to be, 6t minus 12. Now we just need to think about over what intervals are these things positive or negative. So let's think about the velocity function first. When is this going to be positive? So let's just think about, when is 3t squared minus 12t plus 9, when is that greater than 0? Well, let's see, we could try to factor this left-hand side. What I like to do is get rid of this leading coefficient, this 3. So let's divide both sides by 3, and we get t to the third power minus 4t plus 3 is greater than 0. This is pretty straightforward to factor. This is t minus 3 times t minus 1 is greater than 0. And if I have the product of two things, when is the product of two things going to be greater than 0? Well, when they have the same sign. They're either both positive or they're both negative. So this is going to happen when either t minus 3 greater than 0 and t minus 1 greater than 0. So that's the case where they are both positive. Or t minus 3 is less than 0 and t minus 1 is less than 0. So this is the case where they are both negative. Either they're both going to be positive or they're both going to be negative. In either of those cases, negative times negative is positive. Positive times positive is a positive. So let's work through this. So if you add 3 to both sides here, you get t is greater than 3, and t, add 1 to both sides, is greater than 1. So that's one case. Or add 3 to both sides here, t is less than 3, and add 1 to both sides here, t is less than 1. Now we could simplify these further. If t is greater than 3 and t is greater than 1, well, if it's greater than 3, you know you're going to be greater than 1. So really, this t is greater than 1 isn't really adding anything. So we could just simplify this to t is going to be greater than 3, or, and then over here, t is less than 3 and t is less than 1. Well, if you're less than 1, you're definitely less than 3. So this we can rewrite this part of the expression as t is less than 1. So this right over here, this is the case where our velocity is positive. So this is the case where our velocity is positive. Let's just remember that. So this, if t is greater than 3 or t is less than 1, then v of t is greater than 0. Now, if we did it the other way around, if we had this as less than 0, this less than would carry all the way in, and then you would have, then this clause would be, actually let me just work it through just so that we don't get confused, but it's actually essentially just going to be the inside of this interval, but let's just calculate it just for fun. So when is our velocity going to be negative? So 3t squared minus 12t plus 9 is less than 0. Divide both sides by 3. T squared minus 4t plus 3 is less than 0. Factor it. T minus 3 times t minus 1 is less than 0. Well, you're going to have something less than 0 when they have opposite sides. So either t minus 3 is greater than 0 and t minus 1 is less than 0, so different signs, or t minus 3 is less than 0, it's negative, and t minus 1 is greater than 0. So they have to be different signs. So add 3 to both sides here, you get t is greater than 3 and t is less than 1. Well, that's impossible. Something can't be greater than 3 and less than 1. So this whole clause is actually, there's no t for which that is true. Luckily, this is an or, so if we can just make this true, that's enough. So add 3 to both sides. T is less than 3 and t is greater than 1. Or we could say that 1 is less than t is less than 3. This tells us this is when our velocity is less than 0. So we know the intervals where our velocity is positive. We know the intervals where the velocity is negative. Now let's think about the intervals where the acceleration is positive or negative. And this is a little bit simpler algebraically. So when is this positive? So 6t minus 12, when is that greater than 0? Well, that's when 6t is greater than 12, or when t is greater than 2. When t is greater than 2, our acceleration as a function of time is greater than 0. And similarly, if you made this less than 0, this would be less than, this would be less than. And so when t is less than 2, our acceleration as a function of time is less, or acceleration at those times, I should say, is less than 0. So when is both velocity greater than 0 and acceleration greater than 0? So when are we speeding up in the upwards direction? So let me copy and let me paste this. So let's think about this case right over here. Actually, since I'm in copy and paste mode, let me copy and paste this. That's going to be when we're speeding up in the downward direction. We're getting faster and faster in the downward direction. So copy and paste, put that right over here. So let's see, we want our velocity to be greater than 0. Our velocity is greater than 0 when t is greater than 3. So t has to be greater than 3, or t is less than 1, or t is less than 1. That's that constraint. And when is our acceleration greater than 0? Our acceleration is greater than 0 when t is greater than 2. So I could say and t is greater than 2. So how will both of these be true? This is an and here. Both of these have to be true. Well, if t is 2.5, then only my acceleration is positive, not my velocity. And if time is 0.5, my velocity is positive, but my acceleration isn't. So the only way to make both of these true is if t is greater than 3. T is greater than 3, then the first clause is true. T is greater than 3, then the second clause is true. So this is going to be true when t is greater than 3. That means we're accelerating. That means we're going faster in the upwards direction. Faster upwards, I could say. And now let's think about when we are getting faster in the downward direction. When is our velocity less than 0? Well, our velocity is less than 0 when 1 is less than t is less than 3. And when is our acceleration less than 0? So this has to be true, and our acceleration has to be 0, and t has to be less than 2. So what t's satisfy both of these? Well, if t is between 1 and 2, so we get 1 is less than t is less than 2, then we're moving faster downwards. So if we want to think about it in intervals, we could say that we are speeding up. We're speeding up over the interval, not including 3, but from 3 to infinity. And that's why I didn't put brackets, I put parentheses. This doesn't include the endpoints. So that's when we're going faster upwards, and we're going faster downwards in the interval between 1 and 2.